So 11.3 is geometric sequences in series. So obviously we did arithmetic yesterday, which is the ones where we're adding and subtracting things. Geometric is when it's being multiplied or divided, as the case may be. But even when it's being divided, we will typically write it as like 1 over, so we'll write it as a fraction so it still looks like it's being multiplied instead of like division. But anyways. So let's see. I'm just going to write it this way. Geometric sequence a sequence. Whoa, that was not good. A sub n is a geometric sequence if it can be written in the form a times r squared, a times r to the n minus 1, and so on and so forth, for some non-zero constant r. The number r is called the common ratio. So just like we had the common difference for arithmetic, we have a common ratio that's represented by r. The other one obviously was d. Each term in a geometric sequence can be obtained recursively You're back in a boot?
Yeah, I hurt my ankle again. So, I don't even know. It's just unlucky, I guess. I sprained both of them, but one was not as bad.
Wow.
Yeah.
Let's see. Can be obtained recursively from its preceding term. Just so you know, Tyson, we're now in chapter 11.
Wait, we are?
Yeah.
Oh.
You have a quiz to make up, but you don't have to do it like right this second if you have like a study hall or
I'm
something.
trying to do that tomorrow because yesterday I was going to email you, but I had to get my eyes dilated
Oh,
twice.
yes, that's fine.
Because like the first time it just didn't work for some reason. They do these really strong ones, and like I literally could not see till like 11.
Yeah, that's fine. Anyways, but we did that on Monday, and then yesterday we did 11.2. Today we're doing 11.3, but it's not anything super crazy. So, okay, each term in a geometric sequence can be obtained recursively from its preceding term by multiplying by r. And so if we do this recursively, the way that we would write it is a sub n is equal to a sub n minus 1 times r. This is for all n greater than or equal to 2. Now, again, I will say this is what the situation is when we have the previous term, right? But if I don't have the previous term, I can't use this. So the other method that we would use, if I can find it here, is a sub n is equal to a sub k times r to the n minus k. So that means basically like whatever term we do have, okay, it's a sub k, a sub n is what we're trying to find. So a sub k would be whatever term. It can be the first term, it can be the 100th term, it can be whatever. And then raised to the whatever we're trying to find minus whatever the number is of the one we were using. Okay, so this one here will be the one that we use the most, I would say, because it's the most useful, because you don't have to have every term before it to be able to find it. This is how we can find something like the 100th term, okay? Now, typically they're not going to ask you for anything bigger than like the 10th term, but at least you have something that can make it faster in case that they do. So, let's see if there's anything else major I'm missing in here. All right, these ones say to determine a sub 5 and a sub n. So we're finding a sub 5 and a sub n for these following problems. So with 16, they give us a sub 1 is equal to 8 and r is equal to -5. So, a sub 1 is my starting value, and I would recommend that we do a sub n first so that we can find the rule, and then we can go from there. Now, I could just find a sub 5 because all I'm doing is taking this term and multiplying it by -5 until I get the 5th term. But if we write the rule, then we can use the rule. So we'll just do that, a sub n first. And so that's going to be the first term that I have, which is a sub 1. So that's 8 times r raised to the n minus 1. So that's just like the general rule for it. But I want a sub 5. I can use this formula and plug it in, and I'll have, oh, I don't know why I wrote r as r and not -5. Fix that real quick. There. There we go. So anyways, I should have put -5 in instead of r. And then raised to the n minus 1. So now over here, when I want the 5th term, I have 8 times -5 raised to the 5 minus 1. And that's going to end up being 8 times -5 raised to the 4th. Probably going to need your calculator for these ones to like type them in and figure out what it's equal to. I don't even know where mine is. So that would tell me that the 5th term is 5,000. I'm curious if this would have done this for me, so I'm going to erase this for a second. Look at that. It did it for me. Didn't even need my calculator. She needed to write an equal sign. Now, like I said, I also could have just done 8 times -5, gotten that, times -5, and kept going. But if I have the formula, it's easier. I don't have to sit there and keep multiplying by, -5 every single time. 20. A sub 4 is equal to 18. R is equal to 2. Okay, so A sub n would be equal to whatever my first term is. Notice though that this one is 4, not 1. So I have 18 times R is 2 raised to the n minus, now in the last one it was 1 because the first term was 1, but since I'm using the fourth term, this is going to be n minus 4. And then the fifth term would be 18 times 2 raised to the 5 minus 4. So that ends up just being 18 times 2, which is 36. Yeah, this is the term we're finding. Now, what if they asked me to find the first term? Well, not subtracting, but
You just replace the multiplication sign with the division sign. Would that work?
Sort of. So I can either just take 18 and I can divide it by 2. So if I wanted, 1, 2, 3. And then the fourth term is what they gave me was 18, and then I just found the fifth term is 36. I could just take 18 and divide it by 2, which would be 9. Divide this by 2, it would be 9 over 2. Divided by 2 again would be, 9 over 4. I could do it that way. The other thing is, I can still use this formula, and I can find it doing a sub 1 is equal to 18 times 2 raised to the 1 minus 4. The only thing that's different here now is that I end up with a negative exponent, which is 18 times 2 to the negative 3. Well, 2 to the negative 3 is what?
-8.
Not negative 8.
Positive.
What does a negative exponent do? Flips it. So this would be 18 over 8, which would reduce to, 2.25 or 9 over 4. And that would have been our first term. So I can always use this rule for previous terms as well, and it will find it, or I can just, in this case, since it was easy, I could just keep dividing by 2 until I get there. Now, obviously, they're not asking us for that, but I just wanted us to see how we would find it if that was the case. Because I could use this number and change this formula around to use, Wasn't there a number written right here?
2.25.
Okay, I was making sure I wasn't going crazy. I was like, where'd it go?
I guess it never moved it.
Did it decide I wasn't worthy of the number? Okay, you can stay there. That's fine. Anyways, so other ways that I can do that, but all they're asking us for, is a sub n and a sub 5. So far they've told us like a term and the common ratio, but they don't always tell us the common ratio. So 22, negative 2, 6, negative 18, 54, ... So now these are like the ones that we were doing yesterday where we were like, adding something. So we were like, okay, how did I get from the first term to the second term to the third term? And so now I have to figure that out. But knowing that it's geometric, I'm multiplying by something. So what do I multiply by to get from negative 2 to 6? Yeah, -3, and then from 6 to -18, again, would be -3, so that's how you can confirm that it's right. And so that means that my common ratio is -3, and I know that it's negative because the signs are alternating. And I can use any of the terms. So my first term is -2. I don't have to use the first term. It's probably the easiest one to use, but we don't have to necessarily do it that way. So then a sub n is equal to whatever the first term is, or the term that I'm choosing to use, so -2, times the common ratio, -3. And notice I'm putting the parentheses around the common ratio, specifically in this case because it's negative. Up here I kind of just did it out of habit, but when it's negative we definitely need to make sure we have that so it doesn't get confusing, because obviously the exponent, if it's odd or even, I was about to say odd or negative, if it's odd or even will determine if the number is positive or negative. So then we raise it to the n minus whatever term you use. Since I used the first term, it will be 1. Now, another option, if I wanted to use, say, 54, okay, instead, so a sub 4 is equal to 54, then another option I could have is a sub n is equal to 54 times -3 raised to the n, but that was the fourth term, so n minus 4. So both of those would be acceptable. You don't have to use the first term on the quiz or whatever. I will try to catch that if that's what you do. But anyways, if you think you did it right and I mark it wrong or something, then obviously we'll just go back and I think I'll recognize it, but sometimes if I'm doing like quick grading, I may or may not. So if you're like, I think I did this right, then you can just ask me and I can fix it, obviously. Anyway, so then a sub 5, I'm going to use this formula because obviously easier than this one. Well, I guess to a point, but -2 times -3 raised to the 5 minus 1. So -3 raised to the 4th would be positive 81 times -2. What is that, 162? And this was positive, this is negative, so this is going to be a negative 162. The other thing that I can do to make sure that like I've done this correctly is I can go up here and say, well, all odd terms were negative. Since this is an odd term, it makes sense that this is negative. So that's another thing that I can check as I'm going back, because the next term in the sequence should be negative, then positive, and so on and so forth. Cash, you look confused.
You said odd, but 2's not like. Is it like okay?
This term, the next
Okay,
term
that's what I
should be
thought.
odd.
That's what I thought.
Yeah.
Okay.
This is an odd term. No, this, because it's like the 5th term in the sequence would be odd. So obviously that's not always the case. It's the case for this one because I was about to say even. Because it's negative, positive, negative, positive. So it following that every other pattern. Sometimes it won't be that way, obviously. But in this particular case it was. So that's another way I can check. Let's see. 24. 1/2. 2/3. 8/9. 32/27. I have to think about this one for a minute. Any idea what the common ratio is? I think I just figured it out. I'm going to tell you that I think it's probably the easiest to see it between terms 2 and 3, or maybe even 3 and 4. Kind of like disregard these two, what am I multiplying by to get from 8 over 9 to 32 over 27? And I'll tell you it's a fraction.
4/3.
4/3. So, and the way I can go back and check that is 1/2 times 4 over 3. 2 cancels with 4, and that becomes, that becomes 2, so that gives me 2/3, which is the next term. That's why I said I'm going to have to think about this for a minute, and then I went down here and I was like, oh. So sometimes it's not going to be easy, especially when they're fractions, to see right away. You may need to skip a few terms and then look and see how to do it. Because here to here there was nothing reducing, but here there was. And even still, well, I guess technically here there wasn't. But I don't know. I thought it was easier to see it out here. Oh, excuse me. Okay, so that means that 2/3 is my common ratio. So a sub n is equal to, we can use whatever term we want. Like I said, I usually use the first one, so we'll do 1/2 times the common ratio of 2/3. 4/3. I was reading this number here, that's why I'm confused. Oh, that marker does not work. Well, I missed. This is going to be red right now until I get a blue marker. Okay, 4/3. Let me replace that. That was weird. Okay, 4/3 raised to the n minus, this was the first term, so n minus 1. Again, I could choose any of the terms they gave me and go from there. But I'm choosing the first one. So then a sub 5 is equal to 1/2 times 4/3 to the 5 minus 1, which ends up being 4. And so then I would probably just use your calculator at this point and do 4 divided by 3 raised to the 4th divided by 2, same thing as multiplying by 1/2. And my calculator puts it in a decimal, but I think I've showed you before, but under math, there's a button that looks, let me see what happens. So it produced it as this for me on my calculator, but there's a button that looks like this. And so I choose that, and it turned it into a fraction for me, which is 128 over 81. I would say if they're giving you the stuff in fractions, we should leave them in fractions. But like I said, your calculator will do it for you. The other thing you could have done is just, we could have, technically speaking, done this by hand, like to a point, and we wouldn't have even had to use our calculator to that level. But the button for this is under math, and then it's like the second option, or first option. It's option 1. So it's pretty easy to do it if you have, and that's pretty much any decimal. Unless it's like ridiculous, it will turn into a fraction for you. And a lot of times if you input things as a fraction, it will produce a fraction for you. The other day I was doing one, I don't remember if it was for this stuff or for something else, but I was doing it and it finally got to a point that it was like, this fraction's too large, so it like wouldn't do it. It wouldn't turn it into a fraction because it was something ridiculous. Which happens from time to time. But for the most part, it can turn anything into a fraction for you that you would put into it. Any questions about this? Feel okay about it? Need to see another one? Good. All right. So obviously not as many problems out of this section. Let's go with 15 19, 21, and 23.